Okay, so now I'm looking for a difference of squares. I have 3 terms here that have m's and n's involved with them. So I'm going to rearrange this to put those 3 terms at the beginning, and I'm going to put this term at the end. So that would leave me with 2m squared plus 4mn plus 2n squared minus 50b squared. Now the first thing I'm going to do, when I look at all of these, because they're all even, I know I can GCF a 2 out of every term. So if I do that, that's going to give me 2 times m squared plus 2mn plus n squared minus 25b squared. And so now then I can see this is a difference of a perfect square. So I need to see if I can factor this trinomial to make it be a perfect square. And we can. It's actually a perfect square trinomial, where the first term is a perfect square, the last term is a perfect square, and the middle term is 2 times the square root of the first times the square root of the last. So one of those special cases again. So I can just tell by looking at this that it's going to factor to be m plus n times m plus n, which I can write as m plus n squared minus 25b squared. And now then, what's in my brackets is a difference of perfect squares, meaning I have 2 times the square root of the first is m. Square root of the first is m plus n, and m plus n. Square root of the last is 5b, and alternate the signs, 1 positive, 1 negative. And that would be my answer for that one. And then I just saw where somebody asked about 5 through 7 on this one as well. Now that you have this video, again, this is number 4 from Roman numeral 5. 5, 6, and 7 follow the same pattern. So I'm going to give you a chance to work them without me working every one of them. And if you still have a specific question on one of those, let me know.